So, and we go further with the next presenter. This is Sebastian May, he's Managing Director from the CARBOCON GmbH, and he will talk about lightweight design in construction sector, practical examples of carbon-reinforced concrete. Sebastian, stage is yours.
Matthias, thanks for your introduction. Hello and welcome to my presentation. The topic Matthias told already today is lightweight design in construction sectors. Yeah, here it's also possible. Practical examples of carbon-reinforced concrete. At the beginning, I want to say, I think everyone of you knows, we have some large problems at the moment. Not only Corona and the war in the Ukraine. I mean that we use too many materials, resources, and that we produce too many CO2 emissions, especially all over the world and in every sector. But today I want to talk about the building sector. And the building sector, with the building composites and the building materials and constructions, has a part of around 30%. That's the largest part of in total. That's more than the fly industry or the car industry. We, with our civil engineers and building sectors, produce the most CO2 emissions and need the most materials resources. And if we are looking to the right side, we already know at the moment that the global building floor area is expected to double by 2060, so in the next 30 to 40 years. So we know already now that we need more resources than we have. So we have to change nearly everything in the building sector. And the slide before I showed you, we already know not till 2 or 3 years ago, we know it till 10 years before. But what had we changed? If we are looking to the working places outside, I will say not really much had changed by the building sector. On the left side, you see some working sector for new constructions, and on the right side, for a strengthening process. We did it as we did in the last time. There is nothing changed. But why? This I want to, or is there really a rethinking in the field of building sectors? It changed at the beginning of this century. On the left side, you can see a really famous building. It's from Ulrich Müther in Berlin. It's the Ahornblatt. It was demolished at 2000, and afterwards there was a rethinking about, we have a culture in the field of buildings. We have to save them. We have to protect them for the next generations. So we know already we have to use our buildings and our infrastructures in the next time, but we are not changing the process to strengthen or to retrofit these structures. This is also the same for the field of bridges. We have also some problems, but we have to strengthen them with modern materials to be more material safety. Yeah. So now we already know that we have to change something, but here you can see how we did it at the moment. On the right side, you can see a column strengthened with shotcrete or steel reinforcement. So we put on an existing structure or column, which is there since 20, 30, 40 years. We put there a lot of material on the side to use the column and this example for the next 30, 40 years. So we have a much more material and a high dead load. But why we are using not new materials which are more sustainable and durable? Because in Germany we have in the field of building sectors a large problem that we have a high standard. That means that we build and design with standard and guidelines. This is really good because there we have no problems like in Genoa 3 years ago with the bridge. But it's not possible to design and build with materials which are innovative and sustainable because it's not possible. We have no approval. It's not allowed to build with this. And that's the largest problem for us, that we do it by ourselves. Yeah, it's possible, but we say we cannot use it. So we have a lack of standard for these new materials, and to use these materials, you can see on the next slide, we need an application, or we need an approval to applicate this material by an approval only for one project. So if we have an approval, then we can use it mostly, only for this building, not for a building in another city. That's not allowed. That's our problem in Germany, that we have this high standard. But the other something is okay, we have an approval to strengthening existing structures with carbon reinforced concrete. I want to show it you on the next slide. And with this approval, you can strengthen structures in whole Germany. That's good, but we need more of these approvals in Germany, and we are not fast enough. Yeah, and on this slide you can see the difference between a conventional strengthening with shotcrete on the left side. It's with steel reinforcement inside. You need around 7 centimeters of thickness to strengthen existing structures. That's a really massive dead load or construction you put on an existing structures. With carbon reinforced concrete, it is possible to strengthen the structures only with 1 centimeter. So you need not so much material, the dead load is not too high, and the carbon footprint is also really low. So yeah, let's say we can save resources and CO2 emissions. And that it's proved and that we did it in the last time. I don't know how many people here know already about carbon reinforced concrete, but we did it in nearly every state of Germany in the last years. So it is proved and it's shown that it's possible, but the standards sometimes says it's not okay to build so fast as we want to do. Yeah, I want to show you only some pictures of the existing structures we did. Maybe someone of you knows one. One famous bridge is a footbridge in Naumburg. It's from 1894. It's one of the oldest bridges in the new federal states of Germany, with a span of 50 meters and a deep of 1.5 meters. The arch construction is 50 centimeters thin. So it's a really thin structure with a whole load capacity from our culture, from our building culture that our grandfathers did more than 120 years ago. At the moment, we as a civil engineer cannot build such a structure because our standards say it's not possible, that we have to think about it. And for that bridge, we did, and strengthening, the bridge is, it's enlisted, sorry, it's a listed monument, so it was not possible to demolish it and to build it new. And we strengthened the structure on the bottom with 9 millimeters and on the top with 6 millimeters of carbon reinforced concrete. So it's nearly nothing. And another really famous building is in Magdeburg. It's the Hypershell from Ulrich Mütter. It's from 1974. It's also an enlisted monument with a span from 50 to 50 meters. There is no column inside. So it's one of the largest shell structures in Germany or in Europe. And it's really famous, and it shows our building culture, what we can do if we want. At the moment, it's not possible at the standards, and I think also we have no worker who can do it. Is really economic. But that's another story. And on the left side, you can see the problems that we had before the strengthening process. The existing reinforcement was corroding, and it wasn't not really possible to use the shell structure for the next time, so it has to strengthen. And there was one opportunity to strengthen it with shotcrete. The shell structure is 7 centimeters thin by 50 to 50 meter, and there was not enough reinforcement inside. And yeah, with shotcrete, you have to put on the top and on the bottom 7 centimeters, so the dead load is 3 times higher than the dead load which is there at the moment. So it was not possible, and it had to break down. And another opportunity was to demolition it and build it new, but it was too expensive. So our goal was then to strengthen the structure with carbon reinforced concrete. You can see on the right side, and that we can save material. You can see here on this slide, these values are published already. On the left side, this was the opportunity with steel reinforcement or with shotcrete, 3 times higher dead load. And on the right side, you can see the structure with only 1 centimeter on the top and on the bottom. So it was possible to save around 80% of resources and 50% of CO2 emissions. These values are also published, and what I want to show you on the right side, you can see by demolition and build it new, we have 100%, but if we can save our existing structures, it is possible by using carbon reinforced concrete to save 60% of CO2 emissions. And on this slide, you can see that we can save there more than 90% of resources. That's a really big problem at the moment in the building sector, that we have not enough sand. We cannot use the sand from the Sahara. So maybe in 20 years, we cannot build anymore. So we have to think over what we are doing then. Yeah, but what can we do? Of course, not every structure can strengthen. We have to build something new. That's okay, and I think that's also the future. But then we have to use sustainable and durable materials, of course. Not, as we know, they are can corrode and have a lifespan of around 20 or 30 years. So if we use their carbon reinforced concrete, it is also possible to save materials. On the left side, you can see a standard T-beam or double T-beam, and on the right side, one with carbon reinforced concrete by the same load capacity. It is possible to save there around 50% of material and also 40% of CO2 emissions by the same lifespan. So we know already the lifespan is much more longer. At the moment, we say 200 years. Normal steel reinforced concrete has around 50 years. So we can save 3 or 4 bridges or structures in this time. And we did it already in East Germany, in Saxonia near to Bautzen. We built the first bridge made of carbon reinforced concrete. There's nothing steel inside. And it's really the first bridge only with carbon rebars. So you can see there on the left side. Here you can see the working process last year in autumn. It was a normal company who did it. So it's not really a problem for the people, for the workers. And that you trust me, you can see here the reinforcement is only carbon rebars and carbon grids inside the bridge. And after concreting and some tests they have to done, the bridge is now using by normal traffic. Yeah, and the proved lifespan for this bridge is 200 years, normal bridge around 50 to 60 years, so not so long. And at the end, I want to say thank you, and that we have to, of course, we have to use our buildings, our infrastructures, and have to strengthen them, but with sustainable and durable materials. Yeah, thanks for your attention.
Yeah, Sebastian, thank you so much for your presentation, and thank you for staying in time.
No problem.
So now we came to the questions. The classical question to the audience: do you have questions to the speaker? Nobody has a question. Everything is clear. Maybe I have a question. You talked about carbon reinforced concrete. I'm also from this sector, and I would say it could be a game changer in the building sector. But could you tell us something about the limits or the limits of the material, for example?
For the material by themselves, we have no really problems in the field of building sector. The carbon reinforcement has a high strength, about 3,000 to 3,500 Newton per square millimeter, and it's not corroding. So we can build it there as we want, and there's no problem with the position from the outside. The bridge at the end, we had only a concrete cover of 1.5 centimeters. By steel reinforced concrete, you need 5 to 6 centimeters, so much more. Our problem at the moment is that we have no standard, no guideline that allows a normal civil engineer to plan to design such a structures. That is the problem, that we have too high standards to allow a new material to be placed in a bridge or a structure.
Okay, so then we could wish good luck for the future, for next projects.
Thanks.
And thank you so much.